equation 3 here, you can see that we have a compound to the left, a one-way arrow, and then two ions here. So I would say this one, yes, is a strong electrolyte. But let's check A2. So the choice A is basically a compound plus a compound give you another compound. So this is not a dissociation equation at all. This is just a chemical equation, how they get together. So our choice of a strong electrolyte that ionizes in water to conduct electricity will be the 3, or C, sorry. Another study check. Write the equation for the formation of a solution for each of the following. So to write a dissociation equation, we need to know if or we need to observe the molecules that we have, and then we think about it. Is it a strong, weak, or non-dissolvable at all in water? So again, to refresh your memory, if if it dissociates in water 100%, the molecule dissociates 100% in water to its major ions, then we have a strong electrolyte. If the molecule dissociate partially, then we have a weak electrolyte. And then if it didn't dissociate at all, then it is a non-electrolyte. So let's try to write the equation. So here in A, it says K2CrO4, which is known as a strong electrolyte. And then partial dissociation of weak electrolyte of H3PO4. And then dissolving of the solid sugar C12H22OH11 in water. So let's start with writing the molecules. So K2Cr, K2, K2Cr, so K2CrO4. And then we have H3PO4, partially dissociated. And then we have C12H22O12. And it's not dissociated in water. So the first one, you can say that it's a strong electrolyte. Then we have a one-way arrow. And then we have to dissociate these into its ions. CrO4 is a polyatomic molecule. So we have A and CrO4. And then we have 2 of the K, so it's 2K. And then CrO4 as a whole is a negative polyatomic molecule. The other thing is H3PO4, and they said it's partially dissociated, which means we have to have 2 arrows to indicate a reversible reaction. And then it will dissociate into H positive and PO4 negative. But we have 3 of the H's and 1 of the PO4. I got the 3 just from the formula. And then non-electrolyte that doesn't dissolve at all in water, so we'll just write it as it is with no change. That's it. And these are the equations. Okay. missing 3 here. Oh, so this acid is actually a strong acid. When it dissociate into 2 steps, and we will talk about this in chapter 11 a lot. So it first released 1 hydrogen and then H2PO4 as a whole molecule. Then H2PO4 is not stable, and it goes into another dissociation where it will release the hydrogen and leave the PO4 by itself. H2SO4 is the same situation as well. So the other thing that we will be talking about is the solubility. So far we talked about what is the solution and structure of the solution, and then what is an electrolyte and how to determine the type of the electrolyte, if it's strong, weak, or non-electrolyte at all. And now we will talk about the solubility. So the solubility, basically the maximum amount of solute that dissolve in a specific amount of solvent. So basically it's grams over 100 grams of water. Usually it's water under stable temperature. We have 2 types, unsaturated and saturated solution according to the solubility. Unsaturated solution means it still can take more of the solutes. So you can see here, you can add as much as you want on of the solute of the salt or the sugar. If you make a saline solution or a sugar solution, you can add as much as you can to the water. As long as it takes it, it means the solution is unsaturated. When the solution stops taking any more solute and the solutes start precipitating at the bottom, then we have a saturated solution. So you can see here in the photo here, you can add, still dissolve. As long as the particles dissolve, we have unsaturated solution. When the particles stop dissolving and then precipitate, as you can see here, in the bottom of the beaker, then we do have a saturated solution. You cannot take any more. Let's do this studies check. Identify each of the following solutions as saturated or unsaturated. So salt disappear when put in water. Of course, it's unsaturated as long as it disappears. Sugar added to a cup of water doesn't disappear but sits at the bottom of the cup. That's exactly what a saturated solution is. At 40 degrees Celsius, the solubility of KBr is 80 grams per 100 grams of water. Identify the following solution as either saturated or unsaturated and explain. So we have the temperature and we have the solubility of the molecule. Now what will happen, they will keep the temperature in all of the choices, but they will change the amount of either the solute or the solvent each time. So the first one, they basically changed the amount of the solute from 80 to 60. So if the maximum that this solution can take is 80, then 60 will mean that we have an unsaturated solution. Here we have 200 grams of KBr and 200 grams of water. If you try to make it to 100 grams of water, so we can divide 200 by 2, so we'll have 100 grams of water and then 200 by 2, and we have 100 grams KBr. So it means that you're dissolving 100 grams of KBr in 100 grams of water, which means you're dissolving more than 80, which will mean that you have a saturated solution. And the third one, you are dissolving 25 grams of the solute in 50 grams of water. If you want to make it to 100, we can just multiply this in 2 to make it 100, but we will multiply this as well in the 2 to make it a 50. So it's a 50 per 100, which means it's less than its solubility ratio. Then we have an unsaturated solution. The other thing that there are factors that affecting on the solubility. Usually it's temperature and pressure. There are more factors, but we will focus only on those two factors. Temperature on the solubility. So we do have here, this is the temperature and this is the solubility. Okay, and here we have also the temperature and solubility. But here the solutes are solid. Okay, here the solutes are gases. So you can see that as you increase the temperature, the solubility also increases. You increase the temperature, the solubility increase. And here, on the other way, or with the gases, increasing the solubility increasing the temperature decrease the solubility. So gases are the opposite of solid in their solubility, and this is because gases evaporate faster. The pressure, where is for the solubility and the pressure as a second factor that affect on the solubility, we have the Henry's law. Henry's law states that the solubility of a gas in a liquid is directly related to the pressure of that gas above the liquid. Did you ever thought about why your cola drink, when you leave it open, it just turn into basically sugar water? It's because of that. So I will explain to you how does the soda water and the soda or the cola actually is formed. So basically you do have here, so the solution is a blackish color, and here this is a closed can of soda, and all the red and black are carbon dioxide, 1 atom of carbon, 2 atoms of oxygen. So CO2, 1 atom of carbon, CO2, and 2 atoms of oxygen. They're both are here, and they are basically fill in the whole bottle, as you can see, the whole solution when it's closed. As soon as you open it, what will happen is the CO2 is gas will diffuse out from high concentration to low concentration in the air, and then just the pressure will release the CO2 out of the solution, and you will basically end up with a sugar water at the end. So finding when the pressure of a gas above solution decrease, which is this case, the solubility of that gas in the solution decrease. When the pressure or the opposite, when the pressure of the gas above the solution increased, which which the example is a closed can of soda, then the solubility will actually increase, and then you can get the taste of the soda. Study check. Why could we did this? Okay. Soluble versus insoluble compounds. So we have a table to determine if the compound will be soluble or non-soluble, and this is the table. Don't worry about it. If I need it in the test, I will give it to you. These are some examples of non-soluble solutions. So all of these are different solutions, and the solute is not dissolving in, so you can see it by your eyes. And a study check. So again, to